All right, so this is our last set of notes that I will do like this, but we do have a worksheet tomorrow, but this is the last set of notes like this. So today we're talking about other trig identities. So there are like an infinite number of trig identities. So we're going to start with a foundation. So we're going to start basic. So the first basic trig identities we're going to talk about are the reciprocal identities. And you see I've already written them here. So you can pause the video and write them down very quickly. So sine, cosine, tangent are trig functions that you've already learned in geometry. And then I would think in geometry you've already learned cosecant, secant, cotangent, I believe. So you can write this down. I can't remember. I think you learned this in geometry. This is why I wish we were in class, because then you could tell me, because I don't remember. But I think you do. So there we go. So it's secant, cosecant, cotangent. So the reciprocal of sine is 1 over cosecant, or you can say cosecant is equivalent to 1 over sine. And secant is equivalent to 1 over cosine, cotangent is equivalent to 1 over tangent. So these are reciprocal identities, which I hope I review, but I'm not sure. So be sure you write those down. Okay, so there's 6 identities right there. Okay, so let's keep going. So yesterday, we talked about the Pythagorean identity. Which was what? Sine squared theta plus cosine squared theta equals 1. Okay, there's another identity for you. Okay, let's keep going. Then we talked about cotangent theta is 1 over tangent, right? Well, tangent theta, we learned the other day, is sine theta over cosine, right? Well, keeping with the same mindset of reciprocal, then couldn't we say cotangent theta is just flip it? So cosine theta over sine theta. So there's another trig identity. So because cotangent is a reciprocal identity, 1 over tangent, well, another way to write tangent is sine over cosine. So cotangent would be cosine over sine. So there are some more identities. You have these 6 reciprocal, you have this Pythagorean identity, and then you have 2 more quotient identities. Quotient identities. Okay, so these are quotient identities right there. All right, so make sure you do these 6. You understand these 6. You understand Pythagorean identity, and you understand quotient identities. Okay, now what we can do is we can manipulate the Pythagorean identity to create new identities. So number 1, I'm going to say sine squared theta plus cosine squared theta equals 1. Now you can manipulate this one to create a new one. So let's just say, let's divide by sine squared. So if we divide everything by sine squared theta, so if we do it to one thing, we do it to everything, we're keeping the equation balanced, right? Because we're not making one side different than the other, we're keeping it balanced. Well, sine squared of sine squared is 1 plus cosine over sine, we just learned, is cotangent. And 1 over sine squared, if you go back up here, 1 over sine is cosecant squared theta. We've just created another identity. Pretty cool. Okay, we can do one more. We could say, use the same basis, sine squared theta plus cosine squared theta equals 1. But now let's divide by cosine. Okay, so we divide by cosine. Here again, we're keeping the equation balanced because we're doing it to one thing, we do it to everything. Okay, so then what do we get? Sine squared by cosine squared, we know is tangent squared. It's from up here, right? So tangent squared plus 1 equals 1 over cosine, go back up to the top, is going to be secant squared. So what we're learning today is that we're learning a foundation of trig identities, which this is a foundation. These 6 are a foundation, Pythagorean identity is a foundation, and these quotients. So these you really need to know. And then these two are building off of it, which is pretty cool. Okay. So now what we're going to do is just keep manipulating more trig identities. So let's do 2 more. All right. So what we're going to do now is that here's another example. We're going to multiply tangent squared theta plus 1 equals secant squared theta by cosine theta. Okay, we're just going to do what it says. It says multiply tangent squared theta plus 1 equals secant squared theta by cosine. So if you want to pause the video there, you can, because you can see if you can get what I get. So I'll set it up for you. Tangent squared theta plus 1 equals secant squared theta. So this is what you're doing. You're going to multiply this by cosine theta, and you're going to multiply this by cosine theta. So if you want to pause there, you can and see what you come up with, and then come back. Okay, so first thing you have to hear is do the distributive property. So cosine theta, tangent squared theta, so do the distributive property, and then cosine theta equals secant squared theta times cosine theta. Okay, so we just straight multiplied there. Now you need to go to my previous page and look at all your trig identities. Well, tangent squared is the same thing as what? Sine squared over cosine squared. So would that help you, or should you leave it alone? Let's keep going. Plus cosine theta. What about this? Secant squared. Secant squared is what is secant squared? Isn't that 1 over cosine squared times cosine theta? Okay, so I'm just going to manipulate this one side to find a new trig identity, because if I do sine squared over cosine squared, the cosine will cross out, but then you're still left with something there. So let's keep moving. Let's focus on this side. So then you have cosine theta tangent squared theta plus cosine theta equals, well, what happens here is that this cosine crosses out with this one here, because this cosine squared is cosine times cosine. So it just crosses out with one of them. So you're left with 1 over cosine, right? So right here, you're left with 1 over cosine. Well, go back to your trig identities. 1 over cosine is what? Secant. So 1 over cosine is secant. So that means all of this reduces to secant theta. So here's another trig identity. Now, if you wanted to reduce the tangent squared and see what crosses out, you're more than welcome to. So this is what I'm saying. There's tons of trig identities because you can simplify or not simplify. You can leave it like that, not leave it like that. But for this purpose, I'm trying to simplify one side to create a new trig identity. Let's do one more. Let's do multiply sine squared theta plus cosine squared theta equals 1 by cosecant theta. Okay, so let's do that. So here again, if you would like to pause the video and then come back, that's what I would do to try it yourself. But I can set it up first. So we'll set it up. We'll say so we're going to multiply both sides by cosecant. So there, pause the video and try that yourself. Okay, so come back. So it'd be cosecant theta sine squared theta plus cosecant theta cosine theta equals cosecant theta. So we know this is going to equal cosecant theta, I believe. So let's keep going. So let's see if we can reduce this. So here we left tangent square alone, which technically isn't totally wrong. I probably would have kept going, but here's a better one. So sine squared theta and cosecant. So let's think about what is sine squared theta equivalent to? And then cosecant theta. So which way? So there's tons of ways to approach this. So I'm looking at my cosecant. Well, cosecant, we go back and look. Cosecant is 1 over sine. Okay, I think I'm going to go that way. So cosecant is 1 over sine. So if I write 1 over sine right here, right, times sine squared, and if you want to put over 1, you can. You probably don't have to. Plus cosecant is 1 over sine times cosine. Let's see, what else can we do? And what I did here, I'm going to go one step further. 1 over cosine, 1 over sine equals sine, time, because I know cosine over sine is cotangent, and then times cosine equals cosecant. So let's see what we got. Cosecant is 1 over sine. So I know this is going to cross out with that square. So what are we left with? Just sine. It's reduced. Plus, here, I separate this cosine squared out because I recognize that 1 over sine and cosine, well, cosine over sine, if you go back to your trig identities, 1 over cosine over sine is cotangent. So I recognize that. So cosine over sine is cotangent. So you can do that. You can separate that cosine squared into 2 like that if you want. Because cosine over sine is cotangent, and then times cosine is left over, and all this equals cosecant theta, like that. Okay, so sine theta plus cotangent cosine theta equals cosecant theta. So here's the way to approach it. You have to look at what you're dealing with. So if you have cosecant and sine, if those are reciprocal of each other, I would rewrite it and you can start crossing things out. You also need to be on the lookout for cosine over sine, which is cotangent, or sine over cosine is tangent. So you have to be on the lookout. So you have to really understand your trig identities. So it's really good to know this is a foundation. So you really need to be able to recognize these 6, the Pythagorean identity, and then the quotient identities. So the more familiar you are with these, the easier it is to work these out and simplify. So this whole lesson is about simplifying and creating new trig identities. So this really is another trig identity. This is another trig identity. So we could do this all day long. So there's an infinite number of trig identities. So I will stop there, and then I might work out a few questions on your homework to help you out. So I will talk to you later.